Brought to you by Thomas Allgaier and Frennis, this edition highlights key LinkedIn posts on next-gen vehicle intelligence in weeks 51 to 2. Frennis supports automotive enterprises and consultancies with market and competitive intelligence, decoding disruptive technologies, customer needs, regulatory change, and competitive moves so product teams and strategy leaders don't just react but shape the future of mobility.
Welcome to the deep dive. Our source stack for this session, curated from, 2 pretty intense weeks on LinkedIn, it tells a really clear story.
It does.
The conversation around vehicles has moved sharply away from theoretical slogans and toward very tangible architectural shifts.
Exactly. We're moving beyond just software-defined and into AI-defined. The experts we follow were focused on execution, on scale, and on all the complex trade-offs you need to make to turn these ambitious roadmaps into real products.
Absolutely. So for you, the listener, we're unpacking the top next-gen vehicle intelligence insights. We'll cover the architectural foundation, the critical validation needed for that intelligence, and then the global market realities that are really defining success.
Okay, so let's start with that big architectural shift. The core theme seems to be this evolution from SDV, the software-defined vehicle, to the AIDV, the AI-defined vehicle.
Yeah, and H. Guino, he summarized this beautifully. He said that SDV solved how often can we update?
Okay.
But the ADV has to solve the trust equation. What are we allowed to learn? It's a fundamental change in philosophy.
And that's where it gets really interesting. Magesh Sampath broke down the 3 eras for us. First, you had the hardware-defined vehicle.
Right. Static.
Totally static. Second, the SDV, which is alive, it's updatable via OTA. And now the AIV. It's not just programmed.
It's trained.
It's trained, exactly.
And Matt Damasceno expanded on that. He noted the core shift. An AIDV moves beyond millions of lines of if-then code to an intelligence foundation.
It's a real-time learning.
Real-time learning replaces static programming. And the critical reality is that this intelligence needs to live at the edge. It can't just be in the cloud.
And that shift, that requires a new physical backbone, which brings us to zonal architecture.
It has to. Rajesh Sundaram explained why that legacy ECU-centric thinking just couldn't scale.
What was the main reason?
It was optimized for safety and determinism, but not for software velocity or OTA. It just wasn't built for that world.
Right. And Ravinder Mudyu then illustrated the solution, replacing all those distributed ECUs with zonal controllers and domain controllers.
Which enables centralized computing and, crucially, simplifies the wiring.
Kevin Kargar provided some really sharp strategic context on this move, didn't he?
He did. He pointed out that Chinese OEMs are treating zonal architecture as a competitive weapon.
How so?
Their priority is speed and bar-dim reduction bill of materials, so they're making it their default SDV backbone right from the start.
A totally clean slate.
Exactly. While European OEMs like BMW, they're showing strong proof points, around a 30% wiring reduction.
Which is great.
It is, but they carry the heaviest legacy burden. So this structural approach, it directly influences their competitive positioning.
We are also seeing consolidation on the foundational software layer.
We are.
Sean Sahi highlighted the QNX and Vector Alloy Core partnership at CES, which offers a pre-integrated, safety-ready platform.
And that fundamentally changes the OEM's focus.
Right.
They can stop worrying about integrating the basic plumbing.
And start focusing on brand differentiation, on the services they can build on top of that trusted foundation.
And that foundation is increasingly open source. Martin Schleicher reported that the Eclipse S-Core Coalition, which is driven by the VDA, is now over 30 companies strong.
The goal being to accelerate development and cut down on redundant engineering.
And Dr. Fatih Tekin actually quantified that goal. He's talking up to a 40% reduction in maintenance effort and 30% faster time to market.
Those are not small numbers. That's about survival.
Absolutely.
Okay, let's pivot a bit to the operational side. Because more intelligence, it also means more risk. Stefan Lagrasol noted that with SDV's expanded connectivity, the attack surface has just exploded.
It really has. And the required response has to move beyond basic encryption. Ronan Smoley argued that simple SAOC, that's secure onboard communication, has a critical blind spot.
Which is the authenticated attacker.
Exactly.
I think we need to unpack that for a second. What does that mean?
Well, it means if one single ECU is compromised, it can start sending perfectly valid, cryptographically signed messages across the network.
And the rest of the car thinks it's legitimate.
The system has no reason not to trust it. It's a huge vulnerability.
That's why vehicles need intrusion detection and prevention systems, or IDPS.
Ronan Smoley stressed that IDPS detects intent and anomaly. It's asking, is this message normal?
Like, why is the engine being told to shut off at 100 kilometers per hour?
Precisely. And this capability is essential for UNR 155 compliance now.
Moving from security to validation, the shift to AIDV stresses every legacy test method. Hervé Oudin said validation has to evolve from prove the software works to
Prove the AI behaves safely across an infinite ODD.
the operational design domain. That's the environment where the system is supposed to work.
Right. And if that domain is infinite, well, you can't test everything in the real world. It's impossible.
Which is where digital twins come in. Sarah Vanapandi and Animalai stated they are an essential prerequisite for rapid SDV development.
Because they bridge hardware timelines with agile software needs.
He specifically mentioned their role in simulating battery management systems BMS for EVs.
Yeah, and also de-risking OTA updates by testing firmware on virtual fleets first. It's a huge safety net.
But the challenge extends to physical components too. Sony Andrews Jobu Das cited a recent AAA study.
This was a sobering one.
It was. It found that nearly 90% of ADS malfunctions are linked to incorrect sensor placement or just poor calibration after a repair.
It emphasizes that even a few millimeters of misalignment can cause false warnings. The AI can be perfect, but the physical input has to be too.
Speaking of ADAS, the race to level 3 is defined by constraints. That's according to H. Manguino.
He says Germany leads L3 retail reality with systems like Mercedes Drive Pilot.
But not through flashy AI.
No, by mastering constraint engineering, specifically by defining very clear ODDs and speed caps. It's about being robust, not just advanced.
And this is corroborated by that massive strategic deal that Özgür Nurettin Puskul reported.
Toyota's global ADAS order with Bosch.
Yeah. It focuses on predictability, scalability, and hitting the stringent 5-star Euro NCTEPA 2026 requirements.
Again, it's about prioritizing robustness over just having the biggest AI model.
Okay, let's shift to the market realities, the TCO equation.
Right, the total cost of ownership.
Emin Askarov really challenged the notion that SDVs are cheaper to produce.
He did. He noted that any savings from reduced wiring are quietly eaten by the cost of high-performance compute, massive software teams, and all the compliance overhead.
So the BOM cost might go down, but the R&D and systems cost goes way up.
Exactly. However, he did confirm that SDVs do reduce lifecycle costs. With early fault detection, OTA fixes.
It cuts down on recalls.
Right. But the key question is, who pays? He argues consumers don't want to pay for car plus subscriptions.
But commercial fleets.
Commercial fleets are consistently profitable customers because they care about uptime, TCO, and predictive maintenance. For them, it's a clear business case.
Michael Ender Gomez had a pretty blunt assessment from CES, questioning if SDV is actually paying the bills.
Yeah, he suggested it often becomes an intellectual vanity project where nobody is rewarded for stopping when it stops making economic sense.
That's a tough but probably necessary perspective. It emphasizes the importance of core service models.
It does. As Mustafa detailed, that sustainable after-sales growth relies on building trust, transparency.
Using things like digital vehicle inspections.
Right, and optimizing operations using KPIs like churn rate and ARO, the average repair order.
And looking at the global landscape, Scott Newton suggests autonomous vehicles might just mark the end of wide-scale private vehicle ownership.
A huge shift, moving the business model from selling steel to selling services.
That future is clearly being accelerated by global competition. Steve Greenfield noted the existential threat to legacy players.
He specifically highlighted Chinese companies producing 60% of all EVs worldwide.
And they're often structurally designed to undercut European labor and manufacturing.
And the market is responding. Pedro Pacheco pointed out that European customers are beginning to demand access to Chinese-designed vehicles, like the AUDI E5 Sportback.
Which forces Western OEMs to integrate Chinese heart and brains just to deliver a competitive software platform.
It's a really powerful example of market pressure forcing tech integration, isn't it?
It really is. So this deep dive reveals an industry in a selection process, as Stefan Bratzel put it. Innovation has to be backed by disciplined execution now.
The defining characteristics of success in 2026 will be system speed, architectural simplification, and mastering that complex integration of AI, safety, and supply chains.
If you enjoyed this deep dive, new deep dives drop every 2 weeks. Also check out our other editions on electrification and battery technology, future mobility and market evolution, and commercial fleet insights.
Thank you for joining us. We'll leave you with this thought inspired by Guangyang. If the AI-defined vehicle successfully shifts the focus from the driver to the passenger and ultimately signals the decline of private ownership, how do OEMs define customer lifetime value when the customer is only subscribing to mobility services?
Until next time, be well informed. Remember to subscribe.